Welcome to SciShow Tangents. It's a lightly competitive science knowledge showcase. I'm your host, Hank Green, and joining me this week, as always, is science expert Sari Riley.
Hello.
And our resident everyman, Sam Schultz.
Hello.
What is it all about? You guys.
You're supposed to be telling us that, I think.
What's that?
Yeah, I'm just a spring chicken over here. I have to look to the old men in my life. You
come
three.
on.
To tell me what it's all about.
Oh, gosh. You know, I remember when my dad turned 40 and thinking, wow, he's really sort of done. Like they had a big party and there was like over the hill signs and like gravestone balloons. And I sort of took that at face value, which of course it was all in jest, but I took it at face value. And now I do look at the first digit in my age and I think, wow, that's a 4. Holy shit.
Is it your birthday in like 2 days?
Also my birthday. Happy birthday to me.
Happy birthday.
That's what we should be talking about. Cancel everything I just said.
Well,
everybody, my birthday just happened. What did you get me?
If somebody threw me an over-the-hill birthday party, I would be livid, I think. I can't handle that. Does any part of you feel like you are done?
Oh, I definitely feel the age. Mm. You know, I got like my knee hurts sometimes. Yeah. And that way where it's like, it's just like it hurts. My back, my ankles. There's like a ringing in my ears. I have to take my glasses off to look at my phone when it's close to my face. Like
that's peak
all of those
old
memes
person,
of parents. Yeah. Mm-hmm. Yep. All of that stuff has happened. So can you fix any of those for my birthday?
You got any ideas? You should be taking fish oil, for one. I got you a bottle of fish oil.
Fish oil, vitamin D, and exercise combined.
Yes.
Yeah, some carrot seeds. I got you those so that you can grow them in your garden and eat
carrot
some carrots.
Seeds.
Yeah.
They're my favorite kind of seed.
You could have just got him some carrots.
No. He's got to work for them. That's part of the growing old too. You gotta appreciate the little things, like watching a carrot sprout from the ground, so that you can pass it on to your children and be like, "Look at this, the magic of life." And they're like, "We can just go to the store and get a carrot."
Get some carrots.
Yeah.
Okay, so we fixed your squeaky knee. What and your eyeballs? What's wrong with your eyes?
I can't see very good.
Oh, that's
when
the
it's
carrots.
close up.
That's the
That
carrots.
too.
Yeah.
Okay.
Oh, okay. Well, we got you all sorted out.
And we started a GoFundMe for your real life gravestone to celebrate an over the hill holiday, but they were surprisingly expensive. I chipped in $20, Sam chipped in $20, and then we were like, this costs thousands of dollars. It's a big piece of rock.
Yeah. Well, the good news is that that we'll put it into an interest-bearing fund, and in the future
we can buy a lot of gravestones.
Yeah, you have to invest it. And here's the thing: I'm not going to die for like at least 90, 100 years.
Okay.
So
wait a minute.
Cool.
So it'll really have appreciated by then.
What do you know that we don't know?
Yeah, for my birthday, you have to tell me the secret to your immortality. It's coming up in less than a month.
Every week here on Samgents. Every week here on SciShow Samgents, we get together to try to one-up, amaze, and delight each other with science facts while also trying to stay on topic.
This is a great turn of events for me.
Are playing for glory and for Hank Bucks, which I will be awarding as we play. And at the end of the episode, we will have a winner. Now, as always, we're going to introduce this week's topic with the traditional science poem. This week from Sari.
You may wonder why we need a poem or song, because doesn't symbiosis mean getting along? Like when you vibe with a friend and just get each other, or care for your cat like you are its mother. But we're not talking about businessy handshakes or deals. This is Tangents, where science backs up our appeals. So let me introduce you to the Symbiosis trio. These 3 categories, though there are others we know. First, mutualism is all buddy-buddy, like clownfish and anemones, all sandy and muddy. One cleans while one hides in a tentacled nest. They keep each other safe through service and rest. Next, commensalism is where they kind of share. One of them reaps rewards and the other doesn't care. Like a barnacle hitching itself to a whale, it gets a home and a ride, and there's no need to bail. And then there are parasites, where hosts suffer in stride. Their partner takes nutrients as it clings on or inside, whether it's mistletoe sucking life from a tree, or a tapeworm in a dog, or a mite on a bee. So whether they're rude or birds of a feather, symbioses are whenever life sticks together, which happens a lot across land, sea, and sky. I guess we ought to get along if we are to survive.
Wow.
Wow. I learned, I laughed, I cried.
You're crying right now.
Yeah, you can see tears, weeping. You're pulling up your glasses too, so they have room to fall out.
Yeah. It pulls up in there. It's no good. Stuck. Today's episode is about symbiotic relationships. Sari, you sort of outlined it for us. We already know what symbiotic relationships are.
Yeah, I really tried to. I don't like
not
the expression.
Have to do this part of the podcast.
I figured I had to write a poem. I have to do the definition. So now I'm going to try and do some double time. Yeah. Really make the most of my few hours in this mortal coil.
We can make this part obsolete, I think, with enough work from you. I feel like I've always learned that, like, to the common man, symbiosis and parasitism are like opposites. But parasitism is a symbiosis.
Yeah, so colloquially, symbiosis and parasitism, are like opposites, where you use symbiosis to mean something good, parasite to mean something bad. But biologically, symbiosis is just an umbrella term for like any sort of close relationship. And the equivalent term for like a good relationship that benefits everything involved is mutualism. The first biological symbioses we kind of learned about as humans are parasites, but we didn't call them symbioses, and I don't know exactly what we called them, but we knew that there were like intestinal roundworms in people, and they were bothering people's tummies, and this was like BCE, ancient Egyptian medical papyruses. We knew parasites exist, but it took us a while to establish this kind of biological category of two species in a close relationship to each other. And it started with lichens, which surprised me. I didn't think that people would be paying attention to those as far as symbioses, but a lot of people were really into lichens. They were like, these are weird creatures, the fungus with an algae. And they were like, what should we call it? Because it's two things that are kind of living together. And in 1873, one scientist suggested consortium to describe the relationship.
Very official.
And then a German plant physiologist suggested in 1877 the term symbiotismus, which I think at some point in the following decades, we were like, that's a little too fancy. Let's just call it symbiosis.
Why do we have so many? Why extra syllables
going on in there?
Let's. Can you say it for me again? Symbiotismus.
Symbiotismus.
That's sort of like on the opposite side of the calendar from Christmas.
Yeah.
We give our ticks little presents.
Yeah.
Yeah. It's instead of Santa,
have some extra
it's a
blood
dick.
this time.
Yeah.
So yeah, it was all lichenologists who were coming up with the words to describe the relationship, and then from there, people started using symbiosis to describe other plants, mostly like root nodules on plants that were fungus or microbes.
Okay.
That helped with nitrogen fixing. Later on, we decided to do animals too.
This is where it's getting fuzzy now, because like algae, like lichen, is like this thing cannot live without this thing. These things are they don't even separately exist. They have co-evolved to the point where they're basically kind of an individual organism, and they're different species. So you have to be different species, I assume.
Yes, you do. You can't be like you and I cannot be in symbiosis.
Just two guys hanging out.
Yeah, that's just codependence. Yeah. But then like a clownfish can live without a sea anemone. And so it does seem a little bit different to me, where you've got this, like, there's like the mutualism where it's like really in, like, basically they have evolved to interface with each other and on like almost a cellular level. And then there's like, oh, this is nice for both of us, for you to be around. But like, if you're not, that's cool.
So what about like our
vibes,
gut microbiome or something? Is that, because we can't live without that, right?
We could. We did a SciShow about this, and I was very surprised to find that you can live without a gut microbiome. It's just like sucks.
Yeah, it's just no
it's
good.
Much less good at it. Yeah.
But it is like a mutualistic relationship.
For sure.
Right. But I see the distinction that you're making. Yeah.
As we push at the edges of this word, like with any of the words that we go with SciShow tangents, then it definitely starts to get fuzzy, because relationships are all over ecosystems.
Like, is an ecosystem just a billion symbiotic relationships between every organism and every other organism.
Well, look, we gotta call stuff something, or else
That's right. You do have to
we're
call
gonna
stuff
be in big
something.
trouble.
Yeah, we probably shouldn't get the philosophers involved.
No, definitely not. There are a couple different terms. So competition is usually defined as separate from symbiosis, which is instead of two animals choosing to associate with each other, competition is like they're both going for the same apple, both going for the same resource, or both going for the same water or territory or something. And then predation is also considered separate from symbiosis, because if you're just eating another one, that's not parasitism. That's just you're eating it and then it's dead. And then you're the only one left.
It feels a little bit like parasitism, but except it's real quick.
Yeah.
It's a quick parasitism. So have we gotten to the bottom of it? No. Are we close enough? Definitely, because we have to move on to the quiz portion of our show. This week, we're going to play a game called Friend or Foe.
New game, huh?
Yeah.
Is it this or that?
It's like this or that,
well,
but it's Friend or Foe. So as we have discussed, there are different kinds of symbioses. There's mutualism and there's parasitism. And today we're going to be playing the symbiotic version of this or that with Friend or Foe. I'm going to name two organisms. It's up to you to decide what kind of relationship they have. Are they friend or are they foe? And I'm also going to award a bonus point because I feel like I don't give y'all enough points.
Ooh.
If you can guess the nature of the relationship. So not just like, is it good or bad, but what do they do to each other?
Yeah.
So round number 1, when the spotted salamander Ambystoma maculatum lays its eggs, their embryos are not alone. They are in the company of another organism, the algae Oophila amblystomatis, that manages to take over the egg. So are these two friends bonded from before birth, or are they foes with an eternal grudge match to play out?
I think my experience with SciShow Kids gives me the answer to this one.
Well, then Sarah should go first.
I feel like algae's so benign. So I would guess that they're friends. And
you think so, do you?
Yeah. And the egg is like, oh, hey, algae friend. And then the algae hangs out and it photosynthesizes and it provides extra little nutrients for the embryo to go nom, 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 and grow big and strong.
What do you think, Sam?
Same exact answer. I think that these are the guys that have this stuff under their skin and can photosynthesize.
So this algae colonizes salamander eggs soon after the eggs are laid, which gives the algae two opportunities to benefit. In some cases, the algae are ectosymbiotic and consume the nitrogenous waste from the developing embryo, providing oxygen and sugar in return.
Ooh,
so
yumma.
That's nice. But the algae also have the chance to get into the embryo so that when the salamander is born, the algae live in its tissues and cells. This is a environment stressful to the algae due to the limited oxygen, but it gets nitrogen and phosphorates from its host instead. The relationship is the only known example of algae living inside of a vertebrate that we know of in nature. We have done it in labs. So yeah, it's a little photosynthetic salamander, and it's just too good to not know about.
I love when they're friends.
I like when they're friends too. Maybe they're all going to be friends.
Mm-hmm.
I bet
We'll
not.
see. Round number 2. When the ants belonging to the genus Myrmica are finding a place to set up their nest, they may find themselves becoming neighbors with the oregano plant, which responds by releasing a chemical called carvacrol. Is this chemical a welcome present from a friend, or is it a warning sent from a foe?
I'm going to guess that they're friends, because maybe it's a good stinky present where they're like, ooh, come this way. I feel your little pitter-pattering feet. Come and crunch on me.
Why?
And then scatter my seeds. I
don't
think it's a seed scattering mechanism where the oregano's like, come this way. You are good at distributing things, little ants. Bury me in your nest and then I will grow more oregano.
That's better than come to me, ants. Consume my body.
Yeah. Oregano's freaky. I think it's a bad stinky present, and it's like, I don't need you in my life, ants.
All right. So you both got 2 points because you got the right answer on the first one and also the right answer for what the actual relationship was. In the second one, Sari gets nothing.
Oh, no.
Because carvacrol is one of the molecules responsible for oregano's delightful smell. It's also a chemical that kills ants kills them and other pests.
Oregano is really freaky. Kills those pants.
It's a pant murderer. Other pests that might destroy the oregano's roots. But myrmica ants actually have genes that help them avoid death. However, that means that the little oregano plant, which has another weapon in the fight against ants that might eat them up, it has the large blue butterfly. Large blue butterflies are one of a number of butterfly species called myrmecophiles that like to eat ants. What?
What the hell?
Butterflies eating ants out here.
I never heard
to
that
do this, they are social parasites. Their caterpillars produce a scent that tricks ants into thinking that the caterpillar is one of them. To the caterpillar, the hosts of its new home double as an ant buffet, and they spend around 11 months just eating ant grubs. The researchers trying to figure out how large blue moths find myrmica have found that the butterflies are drawn to the carvacrol the oregano plant produces, which points them to where the myrmica nests might be. Okay. So the whole thing is like a symbiotic three-ring circus with the oregano plant recruiting the large blue butterfly as a shield to fight off the ants. An additional fun thing here, long before butterflies and ants had a mutualistic relationship when caterpillars fed on plants and secreted sugars for the ants to eat in exchange for protection in the nest. But at some point, the butterflies decided to become less generous in their dealings with the ants.
What a complicated
so be careful.
History.
Symbiosis can turn around.
What the
and come back to literally bite you to death.
Wow.
But I'm going to give Sam 2 points for that one.
Rats.
It was stinky. I was right.
All right. Final round, everybody. On the ocean floor is a crustacean called Randall's pistol shrimp. It's around it's true. It's around 1.2 inches long, and it doesn't see very well. Ducking in and out of that pistol shrimp's burrow is a fish called Randall's prawn goby.
They're both, Randall found both of them?
Yeah.
I guess that makes sense.
They were together the day that Randall showed up. So are these two friends sharing a burrow, or are they two foes battling with a common space?
Oh, I wouldn't think anybody named Randall's anything could be enemies. Randall's such a nice name. Randall wouldn't stand for it if they were
mean
enemies.
Randys.
Yeah.
Maybe Randall was like playing Zoo Tycoon like me when I was a child and just putting them together and being like, battle to the death. So, could be mean.
I think they're friends. I think they gotta be friends.
What do you think they do?
Oh, yeah. Clean each other or something. I don't know.
I think they're friends. I'm pretty sure I know this one. I think they're friends, and I think the goby acts as like a seeing eye goby for the shrimp. And so the shrimp has a hole that the goby can sit in and be nice and safe. And then when danger comes, then the goby like taps the shrimp and is like, Randall, come hide with me.
Randall and Randall.
Yeah.
So the pistol shrimp and the goby fish have a very handy exchange going on. The shrimp digs the burrow for the two of them, and in doing so, it also sends up small invertebrates into the water that the goby eats. And as the goby eats, the shrimp is able to eat some of the scraps that float around. In exchange, the goby protects the shrimp by lending its eyes. The shrimp has bad vision. As I said, it will leave the burrow and it'll keep its antenna in contact with the fish's tail fin. And if something dangerous happens, the goby will signal to the shrimp by flipping its fin.
Oh my God, they're married.
Randall, get back in our hole.
So Sam has come out of this with 5 points and Sari at 4. Next, we're going to take a short break, and then it will be time for the Fact Off. Welcome back, everybody. Get ready for the Fact Off. Our panelists have all brought science facts to present in an attempt to blow my mind. After they have presented their facts, I will judge them and award Hank Bucks any way I see fit. But to decide who goes first, I have a trivia question. We were just talking about how lichen are a symbiotic combination of fungi with either algae or bacteria. It turns out You might see lichen growing like crusts on a surface, or when they are in their macrolichen form, they can look like leafy bushes. In 2014, scientists were studying a macrolichen species found in Central and South America. They were surprised to find out from their genetic analysis of this lichen that what they thought was one species of lichen was actually more than one species. At least how many distinct species did they realize had been included under the name Dictonema glabratrum.
I'm going to say 20.
Oh, all right.
I was going to say 700, and I'm going to stick with it.
You're going to say 700?
Yeah.
Well, the answer is 126, which is way more than I thought.
Yeah.
That's more than I thought,
but
too.
Not closer to 700 than 20.
That's true. Those scientists blew it out their asses, huh?
Sometimes it all just looks the same. It's like you look the same, and then you start centrifuging it, and you're like, uh-oh.
Yeah, but who knows how many there are out there that they haven't sequenced yet? Who knows? Like, they didn't collect every little lichen out there.
Yeah.
So maybe you're right, Sam. But at the moment, Sarah's going to decide who goes first.
Mm-hmm. I'll go first. So the mutualism between fig trees and some wasps is a classic, I'm going to try to gross you out with science bit of knowledge, but it's genuinely really cool how these two organisms rely on each other. The figs on fig trees are anatomically a bloated stem that has a bunch of tiny flowers inside, which feels kind of backwards because most plants have outside flowers, so pollinators can easily reach them, or the wind can carry pollen or something like that.
What? The flowers are inside of the plant?
Yeah,
they're inside of the stem of the plant.
Yeah, so it's really just like you turned a flower inside out and squished it in.
Oh, okay.
Yeah, it's gross. I don't like it.
It's weird. But evolutionarily, fig trees are doing just fine because they're pollinated by tiny wasps. And here's how it works, just to lay the groundwork. Fig wasp eggs hatch inside a lumpy growth called a gall within a pollinated fig, letting out male and female wasps who have their meet cute inside the only home they've ever known. They mate, the males die, and then the fertilized females burrow out and fly to an immature fig. There, they burrow inside, lay eggs in various flowers, which will become galls, and die. Their life cycle is complete, and a new generation is seeded. As an aside to debunk the ew gross reaction, when you eat a fig, you're not crunching into wasp grubs or exoskeletons, just seeds. The fig plant produces enzymes that leak out from damaged tissues, like where wasps bore into the fig, and that dissolves any insect chunks into macromolecules that are reabsorbed and used. So it's not any grosser than eating a chicken and like you're eating the corn that the chicken ate. And besides, a lot of commercial figs nowadays are artificially fertilized and ripened, which I learned. Fig trees and wasps are linked symbiotically by reproduction, but pollination doesn't happen the same way every time. Some species of fig tree put energy into lots of male flowers that make lots of pollen so that the female wasps inevitably get coated in pollen in their home fig and just happen to fertilize the female flowers inside their egg-laying fig as they run around. This is called passive pollination. But other species require the wasps to put in some more legwork. The male flowers are fairly small and sparse, so the female wasps have to search for them inside their home fig, gather up pollen, store it in little pockets in their thorax, and then when they venture out to find an egg-laying fig, they have to take pollen out of their pockets and sprinkle them on the female flowers in addition to laying eggs. This is called active pollination and is clearly more work for the wasp. And a big question in mutualistic relationships is what keeps them balanced. What's preventing one species from acting selfish? So like in the case of active pollination, what if female wasps just didn't put in the effort to collect and deposit pollen and laid their eggs anyway? Well, it turns out fig trees are savage and have a backup plan for that. In a 2010 study, researchers studied 6 fig wasp fig tree mutualisms, 4 involving active pollination and 2 involving passive pollination, and they found that when active pollinator wasps tried to lay eggs without distributing pollen, the tree just got rid of the fig. Like, no, you didn't hold up your end of the bargain, and it drops those immature figs to the ground and kills all the baby wasp eggs inside.
Whoa,
or
what?
if the trees just happened to hang on to the unpollinated but egg-filled figs, they digested more of the babies, so relatively fewer of them were born.
You didn't do the thing, wasp, so I ate your children.
Yeah. A vengeful tree.
How does it know?
That's what I must have something to do with the pollination, but I couldn't find more information about the biological mechanism of fig
Well,
dropping
I bet no one knows yet.
or behavioral genes involved in active wasp pollinating. So those are open questions. But the moral of the story is don't try to cheat a fig tree when you've had an 80 million year old relationship. They'll know and have evolved a way to get back at you by killing your babies.
That's wild.
That is definitely the moral of the story. I mean, obviously I knew about figs and wasps, but boy, that's a great twist.
Yeah.
I don't know, Sam. That's a really good twist. I don't have any questions. I'm like, I've pictured the TikTok I could make out of this already.
Oh, Christ. Sight, smell, taste, touch, hearing, the classic 5 senses possessed by many people and many animals. But hey, why stop there? In a semi-recent episode of SciShow, we tallied up a potential 33 senses that humans have, including proprioception and balance, just to name a few. But there is one sense that humans ain't got that at least some animals have, and that is magnetoreception, which is the ability to detect Earth's magnetic fields in a way that gives animals that can do it basically like an internal compass. Since humans don't have this sense and animals can't talk, it seems like it's probably sort of hard to prove that magnetoreception is even a thing, but in the 70s, studies of migratory birds interacting with magnetic fields suggested that magnetoreception did indeed exist. But what the studies didn't do was give much insight into how this sense works. And there have been a lot of studies over the years looking at various species with magnetoreception. There are a lot of promising theories, like birds have a protein in their eyes that seems to respond to magnetic fields. Some fish have the good old ampullae of Lorenzini. Is that what it's called?
Yeah, one of those. Something like
Love
that.
that thing. It's an electroreceptive organ that might also detect magnetic fields. But there are a lot of other guys, like sea turtles and bats and whales, that have magnetoreception, but they don't have any identifiable organ or structure or proteins or anything like that that seems to be helping them sense magnetic fields.
Magic.
It's magic. You get the end of it. This is the episode where I reveal magic is real. But in 2020, some researchers from the University of Central Florida proposed a pretty interesting, pretty episode theme appropriate theory to explain how these animals might possess this sense. So not just big, complicated animals have magnetoreception. There's a whole group of bacteria called magnetotactic bacteria that also respond to magnetic fields. And since bacteria are made of only like nothing, and we can see right through them, it's way easier to tell how they do it. So basically, these guys have a crystal of magnetite in them, and the crystals are, as the name implies, magnetic. So the bacteria aren't really like sensing the magnetic field and responding. They're just kind of being like moved around by magnetic fields by the rocks in their guts. So these researchers thought to themselves, hey, where do bacteria like to live? And the answer was inside animals. And maybe these magnet-containing guys are in those animals. So they took a look at a huge database of microbe genetic information, and by golly, they found a variety of magnetotactic bacteria in samples from turtles to penguins to bats to whales. But the problem is, these are just like tissue samples, so they don't actually know where in the animals those microbes are, like where they live, or how the animals might be able to sense the bacteria's alignment. But they're looking into it, and if they find that they're hanging out in nervous tissues or brains or eyeballs, the researchers think that there's a possibility that, in exchange for room and board, magnetotactic bacteria are imparting their magnetic wisdom to all kinds of animals. Or it's all just a big coincidence, and that's just how science works.
That's awesome. That's awesome. I want to know if I have them. What if I have them?
I looked into this a little bit, and there's some people, it's like people who claim that they can sense magnetic fields are generally like laughed out of scientific communities, but I don't know.
Yeah, there's been a couple of iffy studies that show effect. Like if you had like get people confused and then you ask them to point in the direction of the place where they came, they're more likely to have know it in certain circumstances where you don't like scramble their internal magnet. But I think those studies are very old and were not repeated. Were repeatable.
Well, you got to start drinking big old vials of magnetotactic bacteria.
Why not? Why not try it?
Yeah.
Because here's the thing. Like a lot of our senses, we sense them, but like we don't know that we sense them. So there was a lot of subconscious sensing going on. And I don't know, maybe that's how it is for these animals. Like, do they think, I feel the constant tug of north? Or do they just like, that feels right? All right. I think that just if they'd figured it out for sure.
Yeah.
I think you would have had a better chance.
I was more careful about saying that maybe in this time,
Good job.
It's a good maybe. And I'm excited for future research. And I do want to reward scientists for doing that early work, but trees murder baby wasps.
Yeah, that's pretty good.
Because the wasps weren't good enough to them. So congratulations, Sarah, and congratulations on your win. And now it's time to Ask the Science Couch, where we got listener questions for our couch of finely honed scientific minds. It's from @AndrewT. who asks, what is the maximum amount of species that partake in a single symbiotic relationship? Well, as we were saying at the top of the episode, I guess it gets pretty complicated, and that every organism on Earth is kind of in a symbiotic relationship with a majority of the other organisms on Earth.
Okay.
But what do you think, Sari? That's my vague feeling.
Yeah, that's where I was like, it starts to blur at some point. And it seems like right now, with our current scientific understanding, 3 is we like 3s anyway, like throughout sociology and history and whatever.
Mm-hmm.
We like 3 for symbioses as well, where it's like, Sam talked about in a previous episode, like a virus inside a fungus in the roots of panic grass in Yellowstone to help it survive extreme heat, or lichen being 3 actually, which is like a fungus, a yeast, and an algae, or like a sloth and a moth and the algae on its back, or the moss on its back.
Man, the sloth and the moth and the algae on its back is definitely a children's
ring
book.
To it, doesn't it?
Yeah.
It'd be a really good children. It has poop in it too, because the sloth like climbs down the tree to poop, and then the moth larvae grow in the poop, and then they like crawl into the fur where they like,
Sam's a little bummed out now.
What?
Well, I think it's kind of cute, but also really disgusting.
It's very gross. They're dirty. Don't hug a sloth. They're grimy and moist. So yeah, there's a lot of 3s out there, 3-tier endosymbionts, where it's like a thing inside another thing, kind of like a turducken. There are situations with hyperparasites where it's like specifically a parasitic symbiotic relationship, where there's something that parasitizes something else. And in oak trees, there's one instance of 5 hyperparasites where I think one of them parasites the tree, and then one of them like parasitizes another parasite and is like stealing nutrients from them, and then they like human centipede it. Yeah, but
yeah, that's I was thinking those exact 2 words, Sari, and I decided not to say them out loud.
They just came out of my mouth, unfiltered. So I don't know. We kind of answered this in our chatter in the definition, but yeah,
it's complex.
It's complicated. The maximum amount is kind of defined by when does it stop being useful to define it as a symbiotic relationship.
Right. Like, when is it not useful anymore?
Yeah.
And it is also defined by how recently and how many psychedelics you've taken. You start to sort of see it's all in one big mutualism.
When you start seeing a
man.
5th dimension, then you can see we're all connected. I'm sorry. Has anybody ever had a turducken? Is that a real thing?
I have.
You have?
Oh,
okay.
I don't know. I've only seen it on YouTube.
It's not just a useful metaphor. It's a real thing.
No, my mom made a turducken one Thanksgiving.
Wow.
I wrote a song about it. Do you want to hear it?
Yeah.
It went like this. I don't like eating turducken. Turducken's not very good. But I keep on eating turducken just 'cause turducken's food. That was just like my sort of whole Thanksgiving. I was singing that song and like having the leftover cold turducken over and over again. So if you want to ask the Science Couch your question, you can follow us on Twitter @SciShow Tangents, where we'll tweet out the topics for upcoming episodes every week, or you can join the SciShow Tangents Patreon and ask us on our Discord. Thank you to @Michaela Noel, @Sir Wonko the Sane, and everybody else who asked us your questions for this episode. Casablanca.
It's a fun one, yeah.
It is. If you like this show and you want to help us out, super easy to do that. You can go to our Patreon at patreon.com/SciShow Tangents, where you can become a patron. You can get access to things like our newsletter and our bonus episodes. Second, you can leave us a review wherever you listen. That's very helpful. And it also helps us know what you like about the show. And finally, if you want to show your love for SciShow Tangents, just tell people about us. Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
And I've been Sam Schultz.
SciShow Tangents is created by all of us and produced by Sam Schultz, who edits a lot of these episodes, along with Seth Klicksman. Our story editor is Alex Billow. Our social media organizer is Paula Garcia Prieto. Our editorial assistants are Deboki Chakravarti and Emma Dowster. Our sound design is by Joseph Tuna Medish. Our executive producers are Caitlin Hoffmeister and me, Hank Green. And we couldn't make any of this, of course, without our patrons on Patreon. Thank you. And remember, the mind is not a vessel to be filled, but a fire to be lighted.
But one more thing. There's a little crab called Echinocus pentagonus that lives off the coast of Hawaii in the Pacific Ocean, but you won't find them scuttling around in the sand. Instead, they're parasites to the sea urchin Echinothrix calamaris. Baby crabs will hang around the sea urchin's mouth, which is on the bottom, or anus, which is on the top, eating epithelial tissue around the opening. And as the female crabs mature, they climb inside the sea urchin's rectum, eating intestinal cells and fecal pellets while enjoying lots of protection for the rest of their lives. In fact, they grow big enough that they can't enter or exit the butthole without causing serious damage to the sea urchin host.
No! little terrible butt munchers. You name you've discovered the terrible butt munching crab, and you name it Echinocus pentagonus because apparently there's some kind of 5-sided something going on.
Yeah.
But you don't.
Out.
You had so much opportunity to just scour Latin for a terrible butt muncher instead. You could get like Terribilis pitat commendentii.
And that's the terrible butt muncher.
That's terrible butt eater.
Beautiful. Well, scientists, we got to rename this one. Sorry.